Why is this not doing it the way I expect it to? Oh, thank God, okay. All right. So hopefully the mic's still working. It is. Took me a second to figure out how to navigate YouTube's new features. Apparently they have their own encoder now, so I could stream straight on there, but it seems like it just wants to take pictures of my face, and I don't want that, so avoiding that. Yeah. My microphone appears to be working again. I was having issues with it earlier, and then I restarted and changed a couple settings, and hopefully they're fixed now, so I'll be monitoring that. I'm going to be pulling up my stream on my desktop computer so I can keep an eye on what is going on, hopefully read chat, and hopefully mute myself. That would be cool. Yeah, I'm going to hold off for a couple minutes. Hey, Brendan. Nice to see you in chat. It's weird of you to show up so many years removed. I guess I had your little brother in my SAT group this year. That was cool. Yeah. You probably should be studying law, but law is mind-numbingly boring, so I don't fault you for not doing it. Although I do fault you a little bit for coming to watch calculus instead of, you know, doing something productive. That seems a little bit silly. And yes, it is Alex Chinsbro. Yeah, yeah. All right, well, it's officially 7. Let's see how many people are here currently. How many gluttons for punishment we have. Oh, my stream health is a little questionable at the moment. 14 people in here. Hopefully we're not dropping too many frames. Yeah, what is up with this stream health garbage? Oh God, what have I done? Did I just crash the stream? I sure hope not. Alright, anyways. We'll just pretend like the stream health is better than it actually is. And, jump into it. Alright, so, usually start off with the quiz. I'm not going to go through all 4 of them. I'm just going to go through one of them because people actually did really well on this week's quiz. So yeah, let's jump into this. So starting off, let's not save that, and let's get Screen Sketch open. All right, so first deal here is a lot of people are just still not doing things with sketching derivatives. Now, I admit on the test, these are going to be really easy because the only way to multiple choice a graphing problem is to say which one of these is the graph of the derivative. So you don't have to actually sketch on the test. But knowing how to sketch really makes life easier. Step 1 that a lot of people who don't do this right don't do is find all your maxes and mins and go and make a 0 for each one of them. So here and here, I just mark off all those zeros. Next, I say, is that a positive slope or a negative slope? And it is a negative, so I'm going to start with a negative. Then I'm positive in between here and here. And then I'm negative in between here and here. And so it looks something like that on that interval. And that's what a lot of people did wrong. Otherwise, pieces like this guy, a lot of people want to draw something that looks like this, and that's not at all correct. Because this thing always has a negative slope. It's just getting more steep. So I start with some sort of negative slope and go more steep. And that's how I draw that. And for the last bit, it's really the same idea. We start off with a negative slope, then we switch to a positive slope, then we switch to a negative slope. And these are really the parts that a lot of people struggle with. The 9.2 really nobody struggles with. The straight lines, like the straight line I didn't do here, is just a straight line at 1, so it's really boring. And I'm going to move forward to the next one. Oh no, we're not going to do 10. If you don't know your trig derivatives, study them. Alright, let's go to 11. This one had a question that was different in a lot of the classes, and some people had a really hard time with a lot of these. Like, because there's an f of x here, you actually have to take the derivative of that guy and do the product rule here. And there's some nuances to this that are probably worth looking at. The first nuance is that, well, the derivative of f is f prime. A lot of people just chose not to take the derivative of that first guy. Then I do my a prime b, a b prime thing, and I get f prime of x, g of x, and then it's also minus this one. A lot of people wanted to add the third term, but because of this negative, both of our product rule terms are negative. And so we get an f of x, g prime of x. And one thing I like doing in these, some of the other classes had like an x minus 2 in the parentheses, or an x plus 2 in the parentheses, or that sort of thing. Just go through and circle all of the steps, or all of the pieces, the f and g's that you need. And then you'll plug in the right values more consistently. So this is negative 2 minus, yeah, that's right. Negative 2 times g of x, in this case, is 1, minus f is 2, and g prime of 3 is 1. And so this ended up being negative 2 plus 2 minus 2, which is negative 2. And that's that guy. Okay, now another issue was for quotient rule for a lot of people. Some people still think that you can do like top d bottom minus bottom d top, or bottom d top minus top d bottom. That's not true because there's a negative sign. You have to do the one that is the rule. So it needs to be bottom d top, 3x squared plus 5 minus top d bottom, which is 2x, all over the bottom squared. Now, this is good enough for an answer, this unit. However, I do want to point out that a lot of people on this bottom really want to make this x to the 4th, like plus 1 or minus 1 or something, but it's really not that. Just leave it as x squared minus 1 squared. Like, even when we simplify, in like this next unit we're coming to, we prefer it in this form. In fact, we'd even prefer it as x minus 1 squared times x plus 1 squared, because x squared minus 1 factors to x minus 1, x plus 1. And so we really care about where the bottom's 0, and expanding this serves no purpose. And so we're very happy leaving it like that. That's a majority of what people did wrong on this quiz, but overall I was very happy with the quiz scores. I'm really happy when y'all do well, because I grade faster, and that feels good. So I only spent like an hour grading quizzes this weekend, which was killer. Alright, so no questions on the quiz so far. Seems good. Your brother has a strong... Carter, you're creepy, dude. What the heck, man? All right, so I wanted direction from maybe somebody in chat for where I should go next. I brought up a whole bunch of related rates worksheets that I have sitting on my desktop. And if people want a certain kind, I can go and snoop one of those. Determine the arc length. No. That's Calc BC. The homework, please. So we're talking the FRQ worksheet 2018-19 is one of them. So Nathan, you got to be a little more specific. These are questions. And Sonia, when you asked for question 5 on the review worksheet. So yeah, I have this. I need a little more direction. Oh, okay. Nate has the question. I didn't look. All right. So we're looking at which one of these worksheets. Oh, Lord. Related rates worksheet or related rates more? Eeny, meeny, miny, mo. Let's just try them. Ah, this looks like the one. Hey, that's a home run right there. 13, 15, 18, and 21. All right, so 13 and 15 were both pretty beastly. So I think I don't think I have enough room to do these here, so I'm going to snip these and put them somewhere else. Come on. Let's just snag 13 and 15 because those are super worth doing. And then I'm going to go head over and look at what Sonia mentioned there. So edit, copy. And I'm going to dump this somewhere I can work on it. All right. Paste. Sick. All right. Yeah, this looks good. All right. See you. The fun part about 13 is you got to like figure out extra stuff, and there's a little bit of like product rule in it today. We tried to get around the product rule in 8th period or 4th period today, and it did not work out very well. It turns out you can't. So basically you need to know that the surface area of a cylinder is 2 pi r squared plus 2 pi rh. And the reason it's that is because it has a circle on the top and a circle on the bottom, and that's 2 pi r squared in area. And 2 pi r is the circumference of a circle. If we multiply that by the height, we get the wrapper of the cylinder. And so that's our surface area formula. Yes, you will be given this if it is on a test. So yeah, that's what's up there. Okay. Now, in the question, it tells us that it's 600 pi for the surface area, so I plug in a 600 pi here. It also tells us the radius is 10, so if I plug in 10 here, I get 200 pi. If I plug in 10 here, I get 20 pi h. So this is literally just plugging in 10 and 600 pi. This allows you to solve for h, because we subtract 200 pi over, we get 400 pi equals 20 pi h. We divide by 20 pi, we get that 20 is our height. No calculus so far. Like, baby stuff so far, just algebra. Now we do the calculus where we take the derivative of this equation. Now, I am allowed to plug in the 600 pi for my surface area, so the derivative of that is going to be 0. I'm allowed to do that because the surface area is remaining constant, so its rate of change is 0. But I do have to do the product rule for this 2 pi r h nonsense, so this is going to be a fun derivative. We get 2 pi times 2r dr dt plus 2 pi r dh dt plus 2 pi h dr dt, and that's the product rule nonsense. So this was AB prime, and this was A prime B, if 2 pi r is A and h is B. Now that we know all this crap, like this is the derivative, we just plug in all the stuff we know. We know r is 10, we know h is 20, we know dr dt is 4. So if I plug in all that stuff, I get 4 pi times 10 times 4 plus 2 pi times 10 times, I don't know, I'm looking for dH/dt, plus 2 pi times 20 times 4. And if you get this far, you should be home free because it's just simply solving this now. And it works out to be a whole number. So we get 0 equals 160 pi plus 20 pi dH/dt plus 160 pi here. You subtract over the 160 pi's. And we get negative 320 pi equals 20 pi dH/dt. And you're home free. You divide by 20 pi, you get negative 116? Yeah, that's right. And our units are centimeters per second. And we're chilling. That's the answer. So if you had class today, this is probably the second time you've seen this. But if you didn't, you probably have not seen this. That's our dH/dt boy here. Cool. That's one. 15 has a trick to it. Let's ditch all the junk on this page. Boom. Let's do 13 now, or 15. So we have a right triangle, and we have its area is always equal to 6. So 6 equals 1/2 x times y, which are the dimensions of the 90-degree sides, base times height. And so this is one of my equations. My second equation is that the Pythagorean theorem, because I want to know how fast the hypotenuse is changing. It's x squared plus y squared equals z squared. So I have two equations here, and I'm actually going to need to use both of them. This is like two related rates problems in one in order to solve this question. So I know x is 3. I know the area is equal to 6, so I can solve this left equation to find what y is. So I get 6 equals 3/2 times y. So if I multiply both sides by 2/3, I get 4 equals y. Well, that was really useful, because now I know that this is a 3, 4, 5 right triangle. The two short sides are 3 and 4. So the hypotenuse is 5. So, cool. I have found x, y, and z. That's helpful. But the problem is, when I take the derivative of x squared plus y squared equals z squared, I get 2x dx dt plus 2y dy dt equals 2z dz dt. And the reason why this is a problem is I know x, y, and z, but I only know dx dt, which leaves me with dy dt and dz dt as things I do not know. And that's bad. We can't have one equation and two unknowns. So the way I avoid that problem is I take the derivative of my other equation. So if I take the derivative of this equation, I get 0 equals 1/2 x dy dt. And the reason why I got this is I'm doing product rule with 1/2 x being a and y being b. Plus 1/2 y dx dt. And the good news in this equation is that I do know everything but one thing. I just don't know dy dt. So I can chuck everything in there. X was 3, so this is 3 over 2 times dy dt is, that's what I'm trying to figure out, plus 1/2 times 4, which is y, times dx dt, which is 2, and that equals 0. So now I can solve this equation. This is 4, so I subtract it over. 4 equals 3/2 dy dt. I multiply both sides by 2/3, and I get negative 8/3 equals dy dt. Fantastic. Now I know everything but one thing in my derivative of the Pythagorean theorem equation, and it's dz dt is the only thing I don't know, which is what the question's asking for. So I plug in everything. 2 times x is 3, dx dt is 2, plus 2 times 4 times my dy dt, which was negative 8/3. and that equals 2 times 5, which is z, times I don't know what dz dt is. And this is very solvable for our mathletes in this class. So this 2 times 3 times 2, that is 12. 2 times 4 times negative 8/3 is going to be some janky thing. 8 times 8 is 64, so this is minus 64/3. And this equals 10 dz dt. 12 minus 21 1/3, which is what this is negative 9 1/3. And then I just divide by 10. So you end up getting negative 9 1/3 over 10, which simplifies to something that I just don't really care to do right now. I did it in class today, in my 4th period, who asked about this. But yeah, it's the answer on the sheet. So that's cool. Matthew, you're asking a lot of superfluous questions. Holy smokes. And I swear my chat is entirely students I had last year. This is extremely obnoxious. But hopefully I answered the questions Nathan had on here. I want to kind of scoop over to our review, which many of you don't have that yet. But let's pop over there and take a peek at that. So let's ditch all this work, close this thing, and pop over to the review. So, what do we got? Chapter 2, multiple choice practice. That's the one. Cool. So, your question was 5, I believe. When am I getting a face cam? Well, I accidentally did a face cam earlier. Let me scroll up in my chat on my computer and figure out which question Sonia was asking about. Question 5 on the review worksheet. All right, this is question 5 on the review worksheet. It's find the instantaneous rate of change of f of t equals all that garbage. So, the first thing I hope you notice about all this garbage on this page is that the things on the inside of the parentheses are the same. So if we have something to the 1 times something to the half, we have something to the 1.5. And that's a heck of a lot easier to take the derivative of, because I don't have to do the product rule. When in doubt, please try to avoid doing the product rule. All right, so now we pull down the 1.5. I get 1.5 times 2t squared plus 3t plus 3 to the 0.5. And then I chain rule out the inside, which is 4t plus 3. Now I luckily get to plug in 0. That's a pretty homey number to plug in, because then I get 1.5 times root 3 times 3, which is 4.5 root 3, which is the answer. Yeah, so that's that guy. And 6, please, says Sonia. All right, we'll go on to the next one. Calc 3 is getting hard. Dude, Calc 3 was a joke. Come on, Will. You're better than that. I shouldn't be such a hater. Will is smart. All right. So, this question's one of our knowing asymptote ones. So, first of all, we have a hole at x equals 1. That means we need to have an x minus 1 over x minus 1. So that's pretty easy. Then we have a horizontal asymptote at y equals 10, which means my ratio of my leading terms is 10. That's what horizontal asymptote is when it's a number that's not 0 or when it exists. So all I do is make the top multiplied by 10. Now I can't say 10x minus 1 on top. I need to do 10 times parentheses x minus 1, because that's the only way the whole could cancel and, you know, exist. So this function is actually 10x minus 10 over x minus 1, which means a is 10, b is negative 10, and c is negative 1. So if I add all those together, 10 minus 1, I get negative 1. Wow. That's one of the dudes. Okay. So that's 5 and 6. Where are we going next, people? All we have is distractions from the people who are not in this class. And people memeing. Like, thanks, James, for that. Can I do 7, please? Should I just go through this entire worksheet in order? Kumbaya. Alright. Alright, 7 it is. So, 7 asks, gives a position and then asks for acceleration. That means do 2 derivatives. So, my velocity equation is the derivative of position. And that's going to be the derivative of the position. So, take the derivative, I get 2 cosine of 7t, that's a 7, times the derivative of the inside, with chain rule, times 7. And then negative cosine goes to the sine, so this is plus 5 sine 2t times 2. Now I can clean this up a little bit. This is 14 cosine of 7t plus 10 sine of 2t. So now all I do is I take another derivative. So this was v, and so now I'm going to get a. So a of t is okay, I'll show work. Negative 14 sine of 7t times 7 plus 10 cosine 2t, totally forgot the s, times 2. So now I get to save myself some trouble here, and when I plug in pi, cosine of 2 pi is 1, so that dude sticks with us. Sine of 7 pi, at every interval of pi, every iteration of pi, at pi, 2 pi, 3 pi, 4 pi, 0, sine is 0. So this term is 0. So all I really care about is this term, and it's 20 times cosine of 2 pi. Cosine of 2 pi is cosine of 0. They're the same. So that's 1. So this is 20 times 1. So this is 20. And that's it. That's the acceleration of our particle. 6C on the related rates FRQ, please. That looks like a good place to go next. If the chat could be a little less trolly, like, seriously, people. It's hard for me to find questions when people are spamming. I'm really going to need a moderator at some point here. And I don't know who I can trust. Alright, so let's pop over to this guy. And the question was 6C? Yeah. Okay, I gotta snip this guy out of here because I don't have nearly enough room to work on this. Oh, crud muffins, but I need my picture. You know, we're just gonna make do with what we got. Oh, can I cheat this? I can cheat this. Alright, I have a plan. Oh, right. Okay, so I'm gonna pull this question. I'm going to copy it, and I'm going to dump it in my handy-dandy Word file. Cool. Then I can shrink it. If I'm smart enough to do this without a keyboard, which I'm really not, so that feels bad. Oh, come on. Alright, you know, whatever. We're going to make do with what we got here. Super not smart enough to do this. Alright, so let's go to this guy and try copy pasting here. Oh, do I know how to do that? Nope. Alright. Well, I'm really struggling with this. Alright, I'm just going to try to edit it here and work in the margins to the best I can. So did you see, we're trying to find the angle here, which this is our angle down here in the bottom right corner. Because I'm looking at two sides that are changing, and they're the short sides, I'm going to do tangent of theta equals y over x. opposite over adjacent. And so I do need to use a little bit of quotient rule here. When I take the derivative of tangent, I'm going to get secant squared of theta d theta dt is equal to bottom d top minus top d bottom all over the bottom squared. And the good news is I really know a ton of stuff in this picture. X is 4, y is 3. The hypotenuse is 5 because 3, 4, 5 right triangles. So secant is easy to find. It's hypotenuse over adjacent squared. That's 5/4 squared. Oh yeah, I got room on the screen here. I get d theta dt still because that's what I'm trying to find. And then x is 4, but dx dt is which one? Ship A is traveling at a speed of 15 kilometers an hour. So that's a negative 15 for dx dt because it's going towards the rock. Then we get a plus 3 times dy dt, which is 10, and that one's going away from the rock, so it's positive, all over x squared, x being 4. So now it's just some math. We got 30 minus 60 on top. Okay. So that's a negative. What am I doing? I feel like something has gone awry, but I'm gonna believe in myself. Oh yeah, it's a minus in the in our boy, this rule. All right, so really what I get is negative. I'm tilted right now. I think I swapped these. Yep, dy dt is 10, and this dx dt is negative 15. That was incredibly blonde. I apologize for my apparent lack of understanding with what I'm doing here. So really, I should have gotten 40 plus 45 on top, which is 85 over 4. And that equals 25 over 4 times d theta dt. Or 25 over 16. Whoops. More bad math. I multiply both sides by 16/25, and I get that d theta dt equals 85 over, oh my lord, did I forget to square the bottom also? It has not been my day. I blame the teaching calculus for 3 hours and then teaching it for more. So times 16 over 25 here. In case I lost anybody with that, I had swapped dx dt and dy dt because I was being a scrub, and dy dt is definitely 10 and dx dt is negative 15. I also forgot to square the bottom, which was a pretty rookie mistake, which makes our bottom 16 here. Now when I multiply both sides by 16/25, these cancel. I just get 85 over 25, which simplifies to, what, 17/5 or 3.4? Which means the distance between these is growing at that 3.4 rate, which is pretty cute. All right, can I kick people from chat? I can only block people. I can report people on my account. Hopefully that answered the actual real questions I'm getting in here somewhere. Can you do 18 on the same worksheet, says Grace. Nate agrees. Okay, I'm with that. So let's head over that way. So it's not the same worksheet on my computer, so I gotta like peace out and head over to which one? I think it is this one. 18 is the right cylinder that of a constant volume being flattened. Yeah, I think this is the right one. Please yell at me in chat if this is not the right one, but I believe this is. Ah! Okay, I think we're no, stop. Okay, I pop over to a Word document, start a new one, and paste this. All right. Alright, right circular cylinder of a constant volume is being flattened. Oh, I did this one time today already. At the moment when its radius is 3 centimeters, the height is 4 centimeters, and the height is being decreased at a rate of 0.2 centimeters per second. At that moment, what is the rate of change of the radius? So we have a cylinder being flattened. Its volume is constant, which means we cannot keep our R static like we've done so many times in class when we've done cylinder problems, because this isn't like a silo emptying out where the R is always the same. We're like smashing something. So we're going to have to do some product rule here. We're not going to be able to avoid that. So we have V equals pi r squared h for a cylinder. And that's a great place to start. Let's take the derivative of this guy. We get dv dt is equal to, I'm going to call pi r squared a and h b. I get 2 pi r dr dt for a prime times b, plus pi r squared times the derivative of h is dh dt. Now, I am given some stuff in the problem, but we'll see whether or not I was given enough here. So, the radius is 3, so I get 6 pi. The height is 4, so there's a 4 in this, but dr dt is not something I know. So I gotta leave that as dr dt. Alright, in the next one, pi times the radius is 3. dh dt is decreased at 0.2, so a negative 0.2. And then I get over here, do I still have a dv dt? I would argue that I don't. dv dt is 0, I have a constant volume, that's where I get rid of a variable in this problem. And that's going to open a lot of doors for me, because all I have left is dr dt as a variable. Carter, cylinders are circular bottoms. They're called something different if they're an oval-based cylinder. Whatever that's called. So 4 times 6 is 24 pi dr dt. Over here, 9 times 0.2 is a negative. Wait, why did I put a plus equals? That's a plus. This is a negative 1.8 pi here, and that equals 0. So I add that to the other side. I get 1.8 pi equals negative 24 pi dr dt. And then I just divide 1.8 by negative 24. And yeah, that's the answer. Negative 1.8 over 24 equals dr dt. And does that simplify to another set of whole numbers? Yeah, it does. It does. That's 3 over 40, I think. But ultimately, I don't really care. So I would write the answer as a negative 1.8 over 24 centimeters per second. Okay, but now I just idiot checked this, and I'm very questionable about this answer I got. The reason why I'm questionable about this answer is because I realize now that there was actually no negative on this 24, and I idiot checked it by saying, hey, if I'm decreasing my height but my volume's staying the same, my radius has to be increasing. So that means I goofed up, and this is something, please do this. Look at it. I can come back here and be like, oh, dude, I totally derped and made a positive 24 or negative 24. But I can go back and fix that because I caught it, because it's bullcrap that they'd both be decreasing. So please catch your mistakes the way I just did, because that's super, super duper useful. And idiot checking is how I got through college. So, yeah. Just having some semblance of understanding of a physics problem gets you really far in physics problems. Alright. So, what do we got? What sections from the notes packet is going to be on the test? Literally, it is everything in the notes packet. Like, truly, honestly, 1 through 12, 19 and 20, which is what we did in class. Now, are we going to put a lot less of the continuity limits, garbage from the first unit? Yeah. There's probably going to be like 3 or 4 questions from Unit 1 of the 18 multiple choice questions, and like 14 from this unit. So it's really in favor of this unit. In case you don't know, or you were in first period today, like really only fourth period got the details on what the heck's going on with our test. So here's the deal. So our test is 18 questions. It's going to be 12 no calculator questions, and you're going to be given about 25 minutes to do that. Then we switch over and we do the calculator portion. The calculator portion has 6 calculator questions. All of these are multiple choice so far. And it has 1 free response question. So I put the free response on a calculator portion. It's my first time ever doing this, actually. It's pretty exciting. Oh, actually, no, on my final last year I did this. But anyways, on this section, this is where I'd expect to see more of the related rates, because I'm guaranteeing you right now that the free response question is going to be a related rates question. It's going to look quite similar to a lot of problems you have already done. But for this section, you're going to be given a little more time per question. So I'm going to be giving you roughly 30 minutes to do these 7, big air quotes, questions. So we're looking at like a 55-minute test with 18 for multiple choice questions and 1 free response question. So that's what to look at. Now, for our A-Day folks, it's just this. For our B-Day folks, it's a little bit of get wrecked on top of that, because A-Day folks get the quiz on Friday, and B-Day folks get the quiz on Thursday, which is a little bit of this sort of stuff. So that means A-Day folks are going to have another little bit of quiz garbage, and so that their test is going to be quite long. Now, can we take a little powwow break? Yeah, we can. But yeah, if you did not have class today, it means you have a quiz and a test. So it's going to be a little bit longer than the 55 minutes that the B-Day folks will have. So yeah, that's what's up on the test. Hopefully that answers any questions. I just have a bunch of people pressing F in chat. This is super Twitch chatty. What is the squeeze theorem, says Carter? Yeah, that's nothing important. We don't really mess with that. You can check it out. It's just not something we've really looked into yet. What stuff that you may... Is the test tomorrow or Thursday? It is Thursday, Sato. So that's good news. That's why you'd have the quiz and the test on the same day. Like, having the quiz and the test on Tuesday would be a little bit brutal. That'd be not very nice of me. Yeah, Wednesday and Thursday is correct. Do 13 and 14 on the review packet, says Jay Inslee. Oh, that's somebody that was in class today. So which ones? 13 and 14. 13. Hey, might as well put some implicit in here. Oh yeah, and just an FYI to folks, the reason why we're quizzing on some we're quizzing on sections 12, 19, and 20, which means we're not revisiting any of the ones off of this week's quiz. And the reason why I wanted to do that is because these are the key on the test. So I want you studying the same things for the quiz this week as you do for the test. So this is chain rule, implicit differentiation, related rates. Yeah, if you know those 3 things, you cannot do poorly on this test. Those are the 3 big kahunas. I would say implicit's a little less of a big kahuna, and really it's chain rule and related rates. If you're good at chain rule and related rates, you're in great shape going into this test. So that's what to look forward to. Stream went offline. That means I'm probably dropping frames. I'm going to pop out real quick and check my stream health. No, we're chilling. Hopefully it's back. No, it didn't. Well, we'll just keep going here. So let's do some implicit. So implicit, the big idea is to remember the product rule whenever you see it. And that's anytime x is multiplied by y, or anytime you'd have a normal product rule, like a term with y in it times another term with y in it, like y sine y would have product rule. But here we have two very obvious product rules. We have a prime b plus a b prime for the first one, plus 3x times dy dx, that's a b prime, plus a prime b for the second product rule, and that equals 0. Now all we have to do is solve for dy dx. So I subtract over the crap that doesn't have dy dx to the other side. I get negative 3y minus 2xy. And that equals, I can factor out a dy dx now because this crap isn't over here anymore. And I get x squared plus 3x. So now I just divide by x squared plus 3x, and I get that dy over dx equals negative 3y minus 2xy over x squared plus 3x. Just as an FYI, this is probably not how it'd look on a multiple choice question. Most of the time, when they change the answer for the multiple choice question, they change it to be a negative in front and a 3y plus 2xy over x squared plus 3x. And that's generally how it will look. But, I mean, hopefully you can realize that those are the same thing. Okay. Yeah, Liam is confused. I wonder why, Liam. Calc is not where you're at. So I'm going to go on to 14 now, because that was asked about, and I don't mind doing a little more implicit. This is definitely on our test. So the derivative of sine x squared y cubed is a little evil. We have cosine x squared y cubed, but then we have a chain rule that involves the product rule. So a lot of people ask me, like, what order do I go in, Mr. Kennedy? You go in whatever order the problem dictates. So in this case, in order to do the chain rule, I have to do the product rule. So I look back at my original and I go a prime b plus a times b prime. And that equals 1 plus dy dx. The derivative of that right side was pretty gravy. Now this is a bit of a mess because we do actually have to distribute this cosine to both of these terms. So I'm going to do that next. And we get 2x y cubed times cosine x squared y cubed. Plus this garbage, 3x squared y squared cosine x squared y cubed dy dx, and that equals 1 plus dy dx. And now I need to get the dy dx terms on one side and the other terms on the other side, so I just subtracted 1 and got basically this crap minus 1 on one side, and I subtracted this crap over to the other side, and I get dy dx minus dy dx times all this crap. This guy here. And once you've done this, you just factor out the dy dx, and you get a 1 minus that crap. So 3x squared y squared cosine x squared y cubed. And you just divide the stuff on the... You divide this stuff by that stuff, and that's the answer. Stream is blurry for me. Yeah, I think my video quality has been a little shaky. I think my brother's playing online games right now and is destroying my internet slightly. So I'm going to blame him for my stream quality tonight. Because my stream quality has also degraded here. Oh, I'm at normal? I'm at 240p? Oh yeah, if you change it up, it looks good. Yeah, okay, we're chilling. Yeah, my brother's playing freaking Guild Wars 2 with his buddies, or watching basketball or something. I don't know. Anyways, I had a good question during that I saw, and it was from someone. I don't even remember, Philip or James or someone. I don't know. And that question was like, eh, are there any like leet strats for related rates? Well, if I had to give strats, I'd say there are 4 types of related rates questions. The first kind is the like geometry ones. Geometry. So these are like area equations or volume equations, and you have R's and H's and crap, and often within these you want to simplify down a variable, or you need to remember to do the product rule. But ideally, like in the case of cones or cylinders that are constant radius, you can get rid of one of these variables before taking the derivative. So that's one kind. Kind number 2 is Pythagorean theorem ones. Those are pretty customary. I think people know what those are. Type 3 is the trig ones. So both 2 and 3 are triangle-related rates problems, both of these. The trig ones involve angles, the Pythagorean ones don't. Or maybe there's a problem that requires both, like the boat problem, like problem 6 off of the free response worksheet. And then our last piece is ones that don't use calculus. That's our last bit of related rates. And those, for example, are the like dude walking towards a pole, and you use similar triangles to figure that out. Or, for instance, there was the airplane taking up off the ground, and it's at a constant angle of like 60 degrees, and so all you had to do was find what this side was in relation to this. Well, 60 degrees for an airplane, that's like crazy steep. So this would be, the short side's always half the long side, and the medium side's root 3. So this would be 300 root 3 miles per hour. That's insane. This is like a fighter jet or something. But those are the like types of related rate problems, and if you can identify which one of these it is, you really pare down on the amount of work you have to do. Because if you realize, hey, there's the don't use calculus ones, I'm going to avoid doing anything. Or if it's a triangle one, I can immediately say, do I have angles, or do I need to figure out angles? If so, use trig. If not, use Pythagorean theorem. And for the geometry ones, you should be given or know the formulas, and you should be able to figure them out. Number 4 sounds like trig still, you know, sometimes. But in 4, specifically the kind with the guy walking towards the light pole, those are almost always just ratios. Like, it's usually like x and like 6 plus x, and there's like a long side and a short side, and you just solve this. So that's not even any trig. That's just using similar triangles to express the rates instead. Can I do an example of problem of 4? Absolutely. Did you do a 2 derivative problem? Grace, I believe I did do a 2 derivative problem earlier this stream. It was going from position to acceleration, which is on the review worksheet that you have not gotten yet. But I'm going to do an example of 4 now. So I'm going to axe this garbage, go to my sketch, and do a problem here. I can just make one of these up. It's pretty easy. Oh, why did I do that? That was dumb. That was not what I wanted to do. I wanted to go to my sketch pad. All right. So the quintessential walking. Oh, let's do a walking away from the pole. That's exciting. So we have a dude. He's like, let's call him 6 feet tall. He's walking away from a pole. It's like 25 feet tall. Let's make a big pole. Let's say the dude is like 30 feet from the pole. Let's say, what other stuff do they usually give us? Oh, they give us how fast the dude's walking almost every time. So the dude's walking at, let's make it something. He's running this time. What's a good running speed? 6 feet per second? Is that too weak? That might be too weak. He's jogging. So now I have the setup for a problem that I can do without calculus that's a related rate. So what I want to know is I want to know how fast his shadow is growing. So shadow growing. So I'm going to call that x, because that's what I want to find. And if I look just in my small triangle, I have a side of 6, I have a side of I don't know, but I do know that this side is moving at a rate of x. In my big triangle, I have a side of 25, and I know that the end of this big triangle is moving at a rate of 6 plus x. Because the dude's moving at 6 feet per second, and the shadow's moving at x feet per second. And so both of those affect the big triangle, because as the dude walks away, the triangle gets bigger, and as the shadow grows, the triangle gets bigger. And now I just set up my similar triangle crap. I just do 6 over x equals 25 over 6 plus x. And I solve for x, and that's the rate my shadow's growing, which is exactly what I wanted. So I cross multiply 25x equals 36 plus 6x. I subtract 6x, I get 19x equals 36. Why did I write negative 19x? That's garbage. And I divide by 19, and I get x is equal to 36/19. And a lot of people get a little razzled because they're like, another question that can be asked is like, how far is the tip of the shadow moving, from the light pole? And all you do is add 6 to this. So if I wanted to know how far the tip was moving from the light pole, I'd just do 6 plus 36 plus 19. Because like as we said over here, that's our rate of the tip of the shadow moving in our big triangle. And so it's just whatever this is, which is some janky thing. All right. Oh my goodness. Are there any real calculus questions in here? It doesn't look like it. Are we out? Are we ending this stream early? I'm going to give people like 20 seconds to direct me in some direction, or otherwise we're just calling it. Multiple choice number 8. Can you do 8? What, TJ? Why would you ask things? Review 2, says Matthew. 8 sounds good, says Carter. Okay, I'm going 8. So let's look at that review. It's like where? It's like that one. All right. Scroll up. Let's find 8. All right. So 8's very family friendly. So it says if the limit equals 5. So let's draw a little picture. Limit as x approaches 2 equals 5. So here's 2, here's 5. Cool. So that means that the graph approaches on both sides 5. But what happens actually at this point, 2, 5, is completely unknown to us. Because all we know is that it approaches 5 from both sides. So there could be a point here. Like, pretty likely there's a point there. But there could also be a hole there. The point could be like up here, and the hole could be there. And all of those still have the limit as x approaches 2 of f of x being 5. So we know none of these things, so it's not. It could be anything. Problem 3 from the homework last night. Do the, says Sonia, who's asked good questions today and hasn't spam chat with garbage. Multiple choice 9. Here's what everyone has done on multiple choice 9 wrong. You need to rewrite this as 4 sine of 3x squared so that you remember to do all the chains, because this is a 2 chains question. And a lot of people are not doing that and are getting this question wrong. So honestly, everybody I've seen who's realized that this is the equivalent expression to this has done it right. So that's probably enough help for 9. It is a 2 chains question, but they're not hard chains. They're all like multiplying by whole numbers or multiplying by the derivative of sine, which is cosine, and that sort of thing. So that is multiple choice 9. What is 3 from the homework last night? I don't know whose homework that is. 3 from the homework last night. Can you do the related rates on that review worksheet? I absolutely can. That would be fun. All right. So let's pop down here. Oh, that's 3, kind of. Well, it looks like 5. Okay, so this is like a really, really family-friendly related rates problem that was off the 2003 AP exam, I believe. So is it 2003? I think so. So in this question, we have v equals pi r squared h, but r is constant, so this is v equals 25 pi h, because it's a cylinder. So when I take the derivative, I just get dv dt equals 25 pi dh dt. But they tell us the volume is changing at this rate, negative 5 pi root h. So I chuck that in here, and I get negative 5 pi root h equals 25 pi dh dt. And you might see that when I divide by 25 pi, I get negative root h over 5, which is our answer, and we're done. That's it. So it's like we're showing that it's that. And that's it. How many chain questions will be on the test? A crap ton. Like 10. I don't know. A lot. Like almost every question's going to have a chain rule in it. Will there be a mega extra long chain rule on the quest? No. I'm not going to go past 2 or 3 chains. So probably not past 2. I don't remember exactly. I wrote the tests today, which is why I actually know what it looks like now. But yeah, I got asked about 10. I'm happy to do 10. I feel like I'm just doing what people didn't get to in class, because people asked me about like 7, 8, 9, 10, and they're not there. Well, 7 was reasonably tricky, but the other ones are like me. All right, so this is just a limit question. We're going to infinity, so 6 doesn't matter, but 4x squared does, and the derivative, or the square root of that is 2x, but really like an absolute value of 2x. And the bottom's just 8x. So I can compare 2x and 8x, because if I plug in infinity, both those top and bottom are positive, so the absolute value does not matter. So I just get cancel them x's, I get 1/4, and that's it. So the test is only multiple choice and 1 related rates FRQ. Exactly that. Yes, that is the test. Carter, 10 is garbage, but not this 10. If you go to the very back side, this 10 has an e to the x in it. We don't do derivatives of e to the x, so that one is garbage. So if you were curious about that, that's 18. That's not even 10. I don't know what you were thinking, but that's the only thing on that review worksheet that I wouldn't want you to do. If you want more practice with quotient rule and stuff, these are great practice of quotient rule. I'm going to be posting answers. I finished it, and then like I couldn't find it after school, and I need to get home to like troubleshoot my sound and everything, which I fixed, thank goodness. So I will be posting that tomorrow, so you'll be able to check your answers. And so this is a great way of checking your answers on your ability to simplify quotient rule. So that's pretty cool. Is it 8 o'clock? Yeah, it is. Khan Academy time. Yeah, Khan Academy, or my videos for the sections. Those are also helpful potentially. Quotient rule, more like easy rule. That's super troll. Thank you, Sam, for that. Yeah, thanks guys for coming. Thank you for all of you who had actual good questions. Or answered people's questions in chat. Like, those people were very helpful. Basically, no thank you to any of my students from last year who came here. TJ, Matthew, Jay, Brendan. Any of those people were extremely useless. Oh, Nick, I'm sorry, I forgot about you. My bad. And actually, I don't know how much it's gamer time for me, because I have carpal tunnel right now from playing too many video games, so I have like a hand brace, and so I shouldn't be playing that many video games. So we'll see what happens to me. Hopefully in a week or so I'll be back to hardcore gaming time, but right now, not so much. Anyways, that was way too much detail. Have a wonderful night, folks. Get some sleep, and I'll see some of you tomorrow. Now, how do I say stop? Oh, I